In this question, we are trying to maximize x squared plus y squared. So I'm going to call this something. I'm going to say let's like capital A. But we have a condition that it must be that x to the 4 plus y to the 4 is equal to 1, i.e. x and y are related, they're not independent. So what I can do is try to differentiate this thing with respect to x or y, but let's go with x because that's typically what we do. The first thing I need to do is replace this y by a function of x. So we have that x to the 4 plus y to the 4 equals 1, which means y to the 4 is 1 minus x to the 4, which means that y squared is going to be the square root of y minus x to the 4. Now, we don't need to take the negative of this because it must be that y squared is positive. And therefore, a is going to equal x squared plus 1 minus x to the 4 all to the power the half. Just going to write that 4 again. Okay, now we have something to differentiate. dA by dx is equal to 2x plus bring the half down using the chain rule here. 1 minus x to the 4 to the minus a half, and then times by the derivative of the inside, minus 4x cubed. This will equal 0 for stationary points. Which means that must mean that 2x is equal to, I've got a minus here, so it's equal to 2x cubed all over the square root of 1 minus x to the 4. What have I done here? I've done a half times 4 to give me the 2, and then the negative's gone when I've when I've added it to both sides essentially, and I've written this as 1 over. So the next step is that either x is going to equal 0, that is one possibility here, or I can divide through, by the way, I can also cancel out as 2, I forgot about that. Or if I divide through by x, then I'll get that 1 is equal to x squared over 1 minus x to the 4, which would mean if I times through by the square root of 1 minus x to the 4 and then square, then I'll get 1 minus x to the 4 is equal to x to the 4. I've just done 2 steps in one there. And this means, well, we don't actually want to solve for x. Remember, we're asked to show that there's a maximum when x is equal to plus or minus y. And here we had that y to the 4 was equal to 1 minus x to the 4. So this actually means that y to the 4 is equal to x to the 4. And the result of this is that y will equal plus or minus x. So we've got a few different possibilities for what's going on here. We've got x equals 0, or we've got y is equal to plus or minus x. Now when x is equal to 0, a is going to equal so we've got 3 instances for when dy by dx will equal 0. Now don't forget we also have remember we are maximizing x squared plus y squared, and we also have that x to the 4 plus y to the 4 is equal to 1. So when x equals 0, if we just look at this one over here first, y is going to equal plus or minus 1. And x squared plus y squared will therefore equal, well, sorry, I should probably add, remember, I've called it capital A. So A, which is x squared plus y squared, that's the thing I'm going to maximize, is equal to 1. Now we just need to look at the other situation when y is plus or minus x. When y, or should I say when, when y is equal to plus or minus x, we're going to get that A, oh, we should look at, like, sorry, again, we should look at this. We're going to get that, sorry, this one up here. We're going to get x to the 4 plus x to the 4 equals 1, which means x to the 4 is going to equal a half, which means x, or x squared, is going to be 1 over root 2. Again, I can just look at the positive because I've still got x squared. And I've just found x squared because that's what I want to put into A here. So A is going to be 1 over root 2 plus 1 over root 2 because this will also equal y squared because of this relationship. So we'll get 2 over root 2 and therefore we will get root 2. And hence, I can't remember what the question actually said now. I just want to word it correctly. Hence, x squared plus y squared is the maximum when x equals plus or minus y. I'm just going to say this is bigger than 1. The maximum is root 2. I hope that I've made this explanation quite clear. I think this question is quite challenging actually because you're not, you normally differentiate things with respect to x, find turning points. It's a little bit different here because we sort of have this function, but it's got x squared and y squared in it. Y is a function of x, but it's through this condition. It's just the way that it's given, really. Um, and you've got to use both along the way to be able to calculate this. And I've just realized I've not worked out the minimum value, sorry. That was the extra little bit. X squared plus y squared is a minimum when x equals 0. The minimum is 1. We're not actually expected to prove using the second derivative or anything that they're the maximum or minimum here. It's fine to just go with this. On to part B and C. These are shorter parts. We've actually done the main bit. So we're asked on the same diagram to sketch the curves C1 and C2 with equations x to the 4 plus y to the 4 equals 1 and x squared plus y squared equals 1. Well, one of these is familiar and one of them is somewhat unseen, which is the point to this question. So just going to draw some axes. It's only a sketch, remember. Right, I'm going to do it freehand. Okay, one of them's going to be a circle. and that is y, sorry, x squared plus y squared equals 1 in red. Now I've got to think about this one. So what happens here? Well, when x is 0, y is 1, so we're going to get the same points here. And when when y is 0, x is 1 or minus 1, sorry. Got all these different possibilities, and actually I should add these on. So I've got 1, 1, minus 1, and minus 1. So they're going to intersect here. It's what happens in between. Is it, is it going to sort of go around like this, or is it going to go inside? Um, and it might just be worth thinking about maybe, I don't know, let's say x equals 0.5. Now, when we, yeah, I think, well, actually, let me write it as a fraction. X is equal to a half. So that would mean for the first curve, which is C2, we would get a quarter plus y squared equals 1. So y squared would equal 3/4. So y would equal the square root of 3/2. Now, if we look at C1, we're going to get a very similar thing, but actually we're going to get that y to the 4 is equal to 3/4. And that means that y is going to be the fourth root of 3/4. Now, something to think about is when you multiply decimals, you get a smaller answer over time. That means when you find the root of decimals, it's actually going to be bigger. This thing here will be bigger than root 3/2 because it's going to go the opposite way. Like if I was if I was having to square 3/4, it would get smaller. It would become 9/16. If I raise it to the power of 10, it's going to be really small. If I actually find like the 10th root or the 20th root, I'm saying, what do I need to multiply by itself to give 3/4? And that's got to be bigger than 3/4. And, it's going to get bigger the more roots I take. So I've tried to convince you of that. But the upshot is it's going to look a little bit like this. Now, I didn't draw it. Let me try that again because I've got to make sure that it intersects in the right place. So it's just like I've stretched it out a little bit. Oh, I could do that one better, sorry. Okay, and let me just finish by writing that this is x to the 4 plus y to the 4 equals 1. Okay, I'm going to show you the mark scheme version. So I should have made it a little bit more like a square. I think I'd probably get away with what I've done. Um, but yeah, that is your answer. The very last part, it's only 1 mark, but it's actually, I didn't find it obvious to get this answer, but we have that we need a curve C3, sorry, a circle C3 that's centered at the origin. So I can write this down. It's going to be x squared plus y squared equals r squared. I just want to know what r is. I'm interested in where that touches C1. So where it touches x to the 4 plus y to the 4 equals 1. And finally, I'm interested that it touches at the point when x is equal to plus or minus y. So we sort of have these equations to solve together in some sense. And the main thing is that this is going to imply that x squared is equal to y squared. And in fact, x to the 4 is going to equal y to the 4. Therefore, 2x squared will equal r squared. and 2x to the 4 will equal 1, from which we can say x to the 4 is a half, which means x squared is going to be 1 over root 2. And if that's the case, then r squared will be 2 over root 2 by substituting it into this top one, which is simply root 2. This gives x squared plus y squared equals root 2 as the answer. Now, I've solved it algebraically. I think there is potential to do this intuitively because right at the start of the question, I think this is why it's only 1 mark, we showed that x squared plus y squared is a maximum when x is equal to plus or minus y. And we showed, given that this condition was true, and we showed that the maximum was actually the square root of 2. So what we were saying is that basically we have to have this true, and then it will be that x squared plus y squared can equal root 2 if that is true, which is sort of saying that it's when the curves touch. Basically, we are saying we've got different circles centered at the origin, and we can we can make x squared plus y squared bigger, i.e. make the circle bigger, but it must be that x to the 4 plus y to the 4 is equal to 1. And so there will be a point where it reaches its maximum and it just touches. This is my circle. So I think I've convinced myself that that is the case. I think it's quite tough, that bit, to think about it. And I think this bit is tough as well, just for 1 mark. But I hope I've convinced you. Um, this is a somewhat intriguing and confusing question, I think. Not easy, but good effort with it.